To start this video, we'll do a little bit of housekeeping, but what we're going to look at is how to control collisions with the walls. So this requires us to be comparing the position of our entity, whether it's the player, the enemy, or sprites, with available cells on our tile map. So we're looking for things that are, in this case, if it's a 1 or not 0, then we want to prevent going through it. But first I want to go and just clean up a little bit of my project, and we'll just comment out the code there. We don't need to see that anymore on top. Alright, so we got some things on screen, and we want to work on doing some collision detection here. With that, we need to find a place in the code to insert this function. And as you work on your project, again, you may decide that you want to start breaking pieces of this into separate tabs to make it a little bit easier to keep things from becoming so long as you have to scroll through it. My function is going to return nothing, so it'll be void. So we'll title it check wall collisions, and we need to pass into it the player. Now, whenever I do my collision detections for walls like this, I'm going to reference the entity that I'm checking as S. S will stand for sprite, because sometimes I'll be the player, sometimes I'll be the enemy, so I don't want to have two different things I'm worrying about, because the code is the same, but processing doesn't allow me to send multiple kinds of objects to it. So I can only send one kind of object to my function. So I will have a duplicate function that I'm now sending the enemies to later. But theirs is also going to have some additional functionality, but it's going to be very much the same. This is the shorter one, which is why we're starting with this. Begins with a for statement. Like so many things, we just begin with a for because we have to loop through all of our rows, then loop through all of our columns. So with this, we'll go int I is equal to 0. I is going to be less than the number of rows that we have. And then I will increase. Turn twice, close curly. So now I'm going to go end rows. Over here we'll say end function. It's going to be a really good idea on this because we're going to have a lot of nested items here as we're going through this to put in these closing comments to make sure that you have things aligned correctly. Indents are also going to be really important while you do this, because otherwise your code will become completely unmanageable. Now we have another for loop, and this time we'll use J for it. And this, of course, will be our number of calls or columns. And then, nope, I don't want to use I there. J is less than calls, J plus plus. Curly brace, return twice, close curly, comment, and calls. Now we go up 1. So now that we are looping through, this will allow us to loop. Our loop will go first through it will choose the first row, and then it will go through every column in that first row. Then it's going to choose the second row, and it will go through every column in that second row. That's how our loops are going to function. So we say if Tilemap bracket I bracket J is equal to, so we want to find out, is it a wall? Well, walls on our map have a designation of 1, so we put in 1. Now we could, if our tile map was filled with something other than numbers and we use words or something, if that makes it easier, but in this case just keep track of it and you're going to find that it works much better that way. Return twice, close curly. So, and Tilemap. So right now you're looking, you're like, wow, that's 4 sets of curly braces. Yeah, it's ugly, and we still have a couple more to go, because now we get to start writing out a lot more complex if statements to go through what is happening here. So I can put a comment at the end of the line here. Checking if it is a wall. So I could put that on its own line, or I can just put that there. Because this is going to get long enough, we're going to have a mix of comments in here as we do it. So what we need to do is we need to find the distance between this sprite, this entity, and the current cell. We need to do it so cell is each cell of our grid of our tile map. And first we're going to check our distance x and our distance y. And what you'll notice is we're kind of doing the same thing that we did on rectangle collision, because on rectangle collision we figure out our x's and y and our combined half widths and half heights. So we're doing this exact same thing, but instead of doing it with 2 elements, we're doing it between the cells of our grid and the players. So we're figuring these things out. So we're really going to be doing the exact same thing here as we're trying to determine, are we colliding with the wall? Because really we're just passing a cell in, but grabbing it from our tile map, since they don't exist as independent entities. And because they're not in a single array, but they're it's a 2-dimensional array, it gets a little bit messier, which is why we're going to have so many ifs. So with this, we can say so our distance on our x-axis, and I would put this on the same line, but this actually gets long. So if our distance x is, and we always round down, so we use floor, and we need to calculate the distance on the x-axis, because we're going from the centers of the objects again, plus half of its width. So it's the same as what we did before, and we subtract from it. Oh, I forgot a parenthesis because I want all of that in one parenthesis, because then we will be closing the whole thing out when we're all done. So we take, my mouse skills are off. Now right here inside of this, what we're going to do is take J, remembering J is our column. So X is it's our horizontals. So columns are horizontals, that's why we're using J here. And we take our current column value, it starts out at 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9. Multiply it by the width of a cell, and then we add to it the cell width divided by 2. So again, we're figuring out what is the distance apart here. So that's distance on our x-axis, and their distance on our y-axis. And this will be dist y is equal to floor, couple parens, s dot y plus s dot h divided by 2 minus, this time because we're going for rows, we use I, not j. Multiply that by our cell height, and then we add in our cell height divided by 2. something to keep in mind as we do this is everything we're doing is square here. And if all of our cells were all the same size, they're players, enemies, game map, we wouldn't have to, our code would be a little bit shorter. But this allows for the possibility of using non-square size cells. So if we have different height and width values as part of it, we can put those in. So this code it's kind of overkill, but it also is more flexible down the line. So it's a good practice to be thinking about it. Now we need to figure out our combined half widths and combined half heights. So I'll just put a comment here and do combined halves. So again, this is just like a rectangle intersect that we did prior. So we'll have our combined half width is going to be equal to, and we round down in case our values are going to be half of the width of this plus, so we round down because again, if our cells were say 30 and not 32, that would be an odd value. Divided by 2, we get a half, but we need an integer, so we have to round it down. And combined half height, same thing, SWH divided by 2 plus cell height divided by 2. Okay, so now we have our values that we need for it. The time has come to start doing some checking. So first we will check on the x-axis to find out. And again, this is just like what we did, except for we do have one other thing which is why we can't just use their simple rectangle intersect on it, is I need to have it set up. I don't want to, when I'm here, if I move, I don't want to be able to move into that square. I want, when I hit the square, if my move puts me into the square, I need it to bump me back out so I'm no longer in that square. So this is why our wall collision is the same but more than what we have for our standard overlapping checking. So we're going to now check for X overlap, and if X overlap has occurred, then we get to do something with it, where then we're like, okay, we continue on. But if we're not overlapping on both axes, then we don't need to do anything about it. So we're checking for this X overlap on it. And to do that, let's go if. And now with this, we need to grab the absolute value. Remember, we don't care whether it's positive or negative, the distance apart. We just care about, what is that whole value? So we take the absolute value of that, and if that is less than our combined half width, so just like a rectangle collision here, couple returns, put in my closing statement. Now I'll go back. So first we check to find out if we're overlapping on the x-axis, and if the answer is yes, then we check for a y overlap as well. But there's no point in checking for a y if we're not also overlapping on x. So just like a rectangle one. So now check for y overlap. So we go if abs dist y less than combined half heights Now, once again, and Y overlap right there. Okay, so we're making progress here. You can see we got a lot of ifs here. It's really important to put in those closing curlies so you know what it belongs to, and also make sure that our indents are aligned correctly. So that's going to be important. Now, if both of those things have occurred, that means we know that intersection is happening. The next thing we have to do is calculate how much overlap there is on both our X and Y axis. So calculate our actual overlaps. So we'll say our overlap on X is going to be our, which is funny, this is pretty much what we just checked, but now we're going to do some simple math on it. We'll do our combine half width, and we will subtract from that, because the combined half width is the maximum amount they would be overlapping at any one point right here, and we subtract how much, what the actual distance is between their centers, and that gives us our overlap for X, and then our combined overlap for Y. So that now gives us those. So what we want to find out is the collision will happen on the axis that had the smallest amount of overlap. It's slightly counterintuitive, but this is how the algorithm works. We're looking for the smallest overlap. So what we can do is say if overlap X is greater than or equal to overlap Y, so if that is going to be the case, then what we need to, let's put in an ending comment here. And this will be ending our overlap adjustments, because we're going to make the entity adjust its position so it's no longer overlapping with a wall. So if our X overlap is bigger than the Y overlap, then that means Y is the smaller one, so that's the one we're going to take care of. So the way that we do this is we are going to correct our Y position. And the way that we do that, let's just scroll this up so it's a little more centered on the screen. So the way that we correct the Y position is we say if our distance Y is greater than 0, so if the distance Y is greater than 0, so a positive value indicates that the object started below the wall and was moving up when the collision occurred. So it is intersecting its top side. So that tells us that that happened as part of it, which I think we might print out to the console some of these values of which side is hitting, just so it's easier to keep track of. But because if we look at dist Y, is we are subtracting the position of the player from the cell position. So we calculate those pixels. So if the cell is at 100, the player is at 200, then the player, if it moved up and intersected, moving upward, the player's position being greater than the cell position. So when we subtract, we have a positive value. So that now means we were moving up, and that means we have to move back down. So what we have to do is we have to move down by however much we were overlapping. So we're going to tell our entity, our sprite, to adjust its position by the overlap of y. So we're now telling it to move down. And all right, I'm just going to put in here a variable collision side, and it start out as none. Next, I'm going to go here and go side equals top. Actually, I want to put that first and then adjust my position. Just makes me happier that way. And at the end, of our overlap here in Tilemap and over X, because I don't want it to print every time, I only want it to print when there's been an overlap. So we know that here and here. So at this point, this is our overlap adjustments here, our Y overlap. So if that did indeed happen, so right checking for a Y overlap. I think that's where I want it to occur. We'll figure it out. We'll verify. So if my distance was greater and we hit our top here, our other possibility, because we're going to be overlapping, I mean, if the Y overlap is the lesser of the two overlaps, so it's either going to be top, or can have where it will be collision side equals bottom, and then we modify the Y position, not plus this time, but minus, because if we hit on the bottom, we went too low, so we have to go back up, and we travel up by subtracting that value. So now we subtract that value as part of it. Auto format just to clean up the indents here. So that now corrects my so I'll just put that in right there. So if our overlap on X was greater, oh, this shouldn't be an end yet. It's actually should be my else. We need to now fix our X's. Oh, didn't mean to go quite that far, but there we go. So now we need to correct our X position. And we're going to correct our X position similar to what we did as the Y. So if dist X is greater than 0, so that means the player was further to the right that means we just collided with our left edge. So collision to side equals left. So I have to think about the player, or the sprite, versus the wall and the values. And if one is right, the other of course has to be left. So remembering that our distance x here, if that distance is greater than 0, well, it starts out with the player, because the player's x position. So if it's in a column over here, the cell is over here, so the cell has a smaller number. So the player minus the cell, the player being a bigger number, the cell being a smaller number, will have a positive value. But if our overlap, that's the one we're correcting, that means distance x was positive, so it had to be left. So now we just update our sprite's x position. We need to add to it our overlap x. And once again, our sprite's x position, this time if we hit on the right, we have to go back left, so we're no longer overlapping. And we overlap x. Okay. So now, as we look through this, we can see that it's a lot of curly braces. It's a lot of little pieces to keep track of. If you add in your closing curly braces before you put the contents inside your code, you're going to be much, much, much happier. If you don't do that, it's going to be pretty ugly. So now let's try and run it and see. Okay, absolutely nothing changed or is happening because I wrote a function, but I'm not using it yet. So we need to update the player. And then we need to check our wall collisions with that entity. Let's try and run it again. Okay, and now we can see it's hitting on the bottom. Go up here, top, left, go up, right. So we've been able, left, right. So I've been able to verify it is indeed working, and I'm prevented from passing through any walls.